ば、ああ、疲れた。あれ Yeah. K-Style, long time no see. Has it been that long? I don't think it's actually been that long. Anyway, yeah, I had a, what did I have for dinner? Sorry, one sec. One sec. Oh, yes, yes, I had a poke bowl. It was very, mediocre, but, and expensive. Um, but I haven't had the chance to do meal preps. Well, no, so that's the thing. I say it's mediocre, but you know, like I mean in the context of like poke bowls, like in terms of like there's much more mediocre food that I could have eaten, right? I just mean in the context of a poke bowl, it was rather mediocre, but it's good compared to like eating, you know, like raw bread or not raw bread, but like you know plain bread, right? Like you know context, yeah. But yeah. So I had dinner. I watched some anime while eating dinner. Now I'm back to studying. Actually, one thing I've been meaning to do actually is maybe modify my OBS settings a little bit to you know because right now the main screen is this computer, right? But I don't really have anything to show on the computer right now. I if anything all the stuff that's happening is down on this book, right? So I'd been meaning to make a OBS scene where this is the main thing that's going on, but uh I probably should have done that before I started streaming. So we'll do that some other time. Yeah. Anyway, yeah, today's a reading day. That air filter is a little noisy. Actually, I don't think it's picked up on the mic, but it's noisy for me. Yeah. Oh, okay. So, excuse me. All right, back to work. Actually, although honestly, I'm getting to the point where I don't really quite know what's going on in the book. It only took 10 pages. Um, so I think the first thing I need to do is really look up a visualization for Gaussian beams. So let's go to YouTube. Let's mute the side. Gaussian beam propagation. Okay, that looks German. That's probably good. Been doing these. Oh, so actually, that's a good point. I thought I graduated, but I actually need to meet up with them. I'm in a little bit of an awkward situation, so I need to meet with the council. What do you call it? The department counselor about this. So last semester, I took my last class that I needed for graduation, and so technically, I was on academic probation last semester. Reason being that the semester before that, I got below, what was it? I got like a GPA that wasn't high enough for some, like a semester. They say like per semester you need like some minimum GPA. Um, and I got below that. So I was on academic probation last semester. All that really means is that I had to take graded classes for a grade. If, as you know, if the option exists, I have to take classes for a grade, and then I needed above a 2.0 GPA, so basically a C. Um, so last semester I took my last graduation requirement I took the class graded, and then so I ended up getting a C minus, which I thought was okay because I was like, oh, okay, that's passing, and then I didn't really think about it too carefully. But you know, as you can imagine, a C minus technically is less than a 2.0 GPA. So I didn't actually fulfill my, probation like requirements or to the requirements to get off of probation. But at the same time, I passed the class. So in the system, it says that my degree has or will be issued. So, so I'm in this weird circumstance where I didn't clear probation, but I can technically graduate. So I got an email kind of regarding that, or basically the email was just like an automated thing that was like, oh, you didn't clear probation, so here's another semester, get your shit sorted. Um, but so this email popped up yesterday, which is 2 days before. So sorry, tomorrow is the last day to add classes this semester. So I'm like, you sent me this email 2 days before, the final schedule changes are allowed. I didn't plan to take classes because I thought I graduated. Like, I'm working with a professor right now. So like what do I do? So I need to schedule an appointment with a counselor to figure out, like, am I technically graduated? Because like credential, or what do you call it, degree requirements wise, I've graduated. It's just it's not clear if I'm allowed to graduate while on probation. You know what I mean? In fact, it's kind of strange to me that such a loophole even exists, or maybe not a loophole, but such a situation exists, right? Like, how is it that you can pass but not pass, right? so so I got to get that sorted out. But that's what I was doing, and then in terms of what I was literally doing the past few weeks or so, after I assumed I graduated, I just started working full time with the professor. So I was working with the professor initially anyway, right? I was doing research. So now I've just been doing research full time. So I got to figure out I got to figure out what my situation is, because the online system says, yeah, you graduated, cool story, bro. Here, you'll get your paper in a few months. And I was like, oh, okay, like, cool, I've graduated. But I don't actually know. Does the graduation requirement say you have to not be on probation? Because if it does, then I don't think I actually clear it. And if that is the case, I don't know why the system would say that I've graduated. So I got to figure that out. But yeah, I've been doing research. It's been mind numbing, to be quite honest. We finally had some interesting stuff happen recently, but besides that, it's been kind of, I've been perpetually fighting against this differential photo detector here. You can see on screen, well, you can see blurred on screen. I've been kind of trying to fight to get this working for a while now, but it's just more of that. I'm going to a biophysics conference next week, or next week actually, though, so that'll be fun. But admittedly, this like little last minute thing kind of is like it's kind of concerning. Like, I kind of need to graduate so, at some point. So I'd like to graduate at some point. So yeah. Yeah, it's excuse me. Yeah, we'll see what happens. What's the plan after graduation? Well, so what I plan to do is, well, I plan to I'm scheduled to work with this professor for another year, because, well, I applied to grad school a few semesters ago and I didn't get in, so yeah. And then the idea is that we have a paper out. I'm hoping to finish this detector amongst some other things, and that'll hopefully bolster my application, and then I can apply to grad school. So the idea is I'll be working as a researcher. I guess they would call me a post bac, as in, post bachelor's, right? So post bac. But I'd be a post bac working on my current research group, or working in the research group I'm currently in. And then I'd ideally apply for grad school. Now, if that doesn't work out this second time, I think I need to probably just kind of step away from academia for a while, because not that, like, I think what I mean to say is that I'm gonna try to give it my best shot, so to speak, next application cycle. But if that doesn't work, then I think I do need to kind of reconsider what my options are. So I haven't really thought about that too deeply, but The current plan is presumably that I would, do good research and then I'd get into grad school and then I'd suffer for another 6 years, 6 to 8 years. Um, you know, yeah. Actually, this is part of the reason why I'm going to that conference in the next week. Um, I'm thinking of applying to like biophysics and neuroscience and stuff. That's kind of more where my interest lies. But admittedly, I don't really know what kind of like work is being done currently. So the idea is I could go to this conference and kind of wander around and look at people's presentations and stuff, and I'd be able to see the what the cutting edge. Excuse me. I could take a good look at the what the cutting edge research is like, and you know so on and so forth. So that's kind of the plan. So that's short term plan. Like the short term is that ideally I would do research. I go to conferences. I network a little bit, and then I ideally somehow get into grad school somewhere. Now if that doesn't work out, admittedly I don't have a quite a good plan. I have something's lagging. Anyway, I do have a absolute like worst case scenario backup plan, um, and that is to go to Japan and work as a ESL teacher for a little bit. I think I have some skills that aren't normal, that people don't normally have, that I think I can leverage in such a circumstance. And also I just kind of miss Japanese food. But I think my bachelor's should be enough to qualify me for like a short ESL, like a jet program or something. So that'd be the worst case scenario. And I say worst case not because it's a horrible job, although I've heard it can be kind of, stressful, but mainly because it's considered a dead end job for yeah, it's just considered a dead end job. You don't do ESL teaching, at least in Japan. You certainly don't become an ESL teacher assuming it's not really a route that has what do you call it, like upward mobility, so to speak. So um yeah, but that is like a last minute, okay, if I really need to just do work, what could I do? Well, that's one way to earn not good money, of course. That's not going to be good money, but I think it'd be an interesting experience. Um, but as I said, it's kind of a dead end thing. So really, what that would be to do is to kind of, so really, the whole point is that what I'm trying to say is that doing ESL teaching in Japan would be mainly would mainly to answer the question, is working in Japan a viable route? Because you do the ESL program, I'd leave, and then presumably if I did think it was worth working in Japan, I would then come back on my own dime, and then try to find work. So that's like, so I do have some backup plans. There are a number of options. I could continue to try to do research. I don't want to overstay my welcome too much, of course, but I think there are people I can ask and then do further research. So if I don't get into grad school next year, then one route obviously is to continue doing research. Personally, I would like to just take a few years off, but I've already done that before, after high school. So, I mean, I guess I didn't take them off, but it's treated as me taking it off. So, yeah. Enough about me. Enough about me. How's your life? Just to say that, long story short, what's the plan after graduation? Grad school or research and then grad school, or I haven't thought about it yet, really. It's really the answer. Yeah. But yeah, enough about me. Enough about me. Yeah, let me, although I'm gonna play this video so I can, I do want to do my best at research, so I need to learn this shit. Actually, I guess I kind of wanna. Hmm. I was just looking at this video and I was like, actually, we have a laser downstairs. If I really wanted to see this happen, in real life, I could just, you know, throw it on a breadboard and then run an experiment. Excuse me. So anyways, what's going on in life? Yeah, again, no pressure. I mean, I ask, but you're not obligated to answer, of course, right? it's just. Well, that's the thing. That's the thing. I, I, and this is kind of the thing. I've been thinking about because I do intend to, or at least I currently do still have the intention of applying to like Hololive for Hololive production and stuff. Like a proper VTuber agency. And so, one thing I've put a lot of effort into is thinking about like what would my business proposal be? I don't think you typically have to take a business proposal with you. I just think that if I were able to get to the interview step, I would need a business proposal to be able to get past the first stage of interviews, just because, um, you know, I don't think I really fit the conventional VTuber. I mean, unless you can go find another VTuber that's studying physics at 8:53 p.m. I mean, by all means, I must not be the only one, but I don't think we're all that common, especially if Twitter is any indication, right? And sorry, the only the thing I'm trying to say is just that um, the business proposal I would present would presumably be a stream actually that doesn't really focus too much on the streamer, which might not make a lot of sense, but um, I'm taking some inspiration from, say, Amelia Watson from Hololive EN, right? And I think she does. I'm always impressed at how she's able to kind of what do you call it? Like leverage the skills of the community in her content creation. And I think something along those lines would be good. But like I like there's a lot of cool things I think out there that I think is worth presenting. So I've been meaning to make like Well, the one I'm trying to say is that my life isn't that interesting. So my business proposal would have to be not about make not about being like, hey, I'm an interesting person, so hire me. It'd be more like, hey, I know interesting stuff that other people are doing, and I want to show people that that interesting stuff that other people are doing. So hire me. Like that's kind of maybe not the literal business proposal I'd make, but it would incorporate some of that, right? Because just sorry, the reality is I'm not that interesting. Unless you want to hear about day, let's see, it's been a year and a half, so that's day like 500 about of oh hey this detector that doesn't fucking work. Like, there's only so many hundred times you can describe how a detector doesn't work before people get tired. So and then you ask like, "Oh, is there really nothing else you've been doing?" And it's like, "Well, no, I've been reading this book and I've been watching videos, but that's all because I want to know how this works or why this doesn't work." So at some point you reach a limit in how interesting that is, right? Yeah. So, well, actually, wait, no, I was still watching this Gaussian beam thing. Yeah. Then you choose how to bring yourself to. Well, I mean that's while that's entirely true. Um, that's that's something that interesting people get to say. Like an interesting person can just choose to not show their interesting parts, right? But a boring person can't really construct interesting things out of thin air, can they? And I suppose you could argue that is a skill. And I do agree, being interesting is more of a skill than a state of being, right? I think you have to actively choose to be interesting in order to be interesting. So I totally agree with that idea. I don't think it's something that you're just like, I don't think it's really, I don't think it's all like part of it is luck, okay? But I think, the reality is an interesting person puts a lot of effort into being interesting, and I do want to recognize that effort. But nonetheless, you do have to have something that is interesting, right, to show. So in my case, that interesting thing I don't think really exists. So while someone else that's interesting can modulate their lives to seem less interesting, someone that's boring I don't think can construct interesting out of nothing, right? They'd have to well, I mean, right. So it's possible to construct interesting things, right? But you can't do it out of nothing. And I'm saying that resource that from which you can construct being interesting is not something I possess. Now, what is that resource? Well, that's quite an easy answer, actually. That's time. I don't have time. I can think of stuff that might be interesting to people, but I don't have the time to do it. So hence I'm not interesting, which I don't think that's too, what do you call it? I don't think that's too contentious of an idea. I mean, I think it's important to recognize that when we look at popular content creators and streamers and stuff, yeah, they're interesting, and yeah, not all of us have the same opportunities, but in order to materialize those possibilities, they have to put in a significant amount of time and effort, and while it could be argued that no, my point is just that it's valuable to recognize that time and effort, regardless of the whole, like if it's whether everyone has such opportunities, they at least have put in the effort to materialize those opportunities, right? So obviously I don't want to take away from that, but I do think time is really the fundamental resource there, and the reality is I just don't have that time. Yeah. Which is perhaps unfortunate, but it's a trade-off that you got to make, right? Okay, so the Gaussian beam is what I expect it to be. Okay. They call I don't know if this is the only reason why they call a Gaussian beam, but they're saying that the Gaussian beam is called a Gaussian beam because when you look at the intensity profile, and that's that big glowing dot in the middle of the screen, and you kind of divide the intensity profile into its x and y axis, and then you just map it as a line where the height is the intensity, then you see that the two axes do form relatively Gaussian curves, again, of intensity. Hence, it is a Gaussian beam, which seems very sensible. I just did want to verify that that was what they mean by a Gaussian beam. There's, of course, I think there's some other factors that I haven't really taken into account in the, sorry, I gotta turn that off. Taken into account into the definition, but I think for the time being, it's okay just to kind of mentally start that away. Right, so when a Gaussian beam passes through a lens, it's transformed into a different Gaussian beam. That I can understand, because you could send something through a lens, and then you could like focus it, for example. So let's say you have a collimated or like, perfectly parallel Gaussian beam. So it doesn't expand or contract as it, propagates through space, and you send it through a lens or something. So that could maybe make it diverge, in which case now it's not a collimated or parallel Gaussian beam. Now it's like a diverging one, or you could use a lens. You could converge it, or you could like you could do stuff, and you could kind of send it through like a circular lens, in which case, or sorry, not circular, a cylindrical lens, which those are funny things, but they really they bent, or they kind of like warp the beam, but only in like one axis. So like if you sent this circular Gaussian beam, as you see here, or sorry, this relatively, what do you call it? When you like put together, it's like a circular, or it's like I guess it's kind of well confined, right? This circular dot here. Like if this one goes through like a cylindrical lens, it would actually turn into like this really wide like thing, like an ellipse. Not even an ellipse really, like, because I think most, is it exponentially? Does it turn it like an exponential? Anyway, it turns really wide. So, but that would still be a Gaussian. It's just like asymmetric between x and y. So this statement here that they, in the book here, that says when a Gaussian beam passes through a lens, it's transformed into a different Gaussian beam. That seems like a reasonable statement, yeah. Let's see. For the most part, ray optics is sufficient to predict the position of the beam waist and numerical aperture. Beam waist is, and I realize the screen is blurred, but I also realize that, probably not really paying attention too much to what I'm saying. But beam waist is this narrow part of the green pair of lines. This is the minimum size of the beam. Just for a perfect beam, it should be a point, but for when I get food, oh yeah, okay. At some point I'll make it so that the camera is the big screen. The camera is actually recording at 1080p, so there's no reason why I can't do it. It's just like resolution wise, like like as usual. Is there any problem? I don't want to unblur it right now because this window is actually this is my work window, so it has some stuff that's pretty identifiable. So I won't unblur it, but okay. But yeah, I've been, like I went through the trouble of setting up this camera. I probably should use it more, but yeah. I mean, again, if you find it, well, oh shit, I don't want to go into a tangent again, but I think, and actually this kind of pertains to the interesting thing. I think something being interesting is less on, like if you find this stream interesting, I find that to be a stronger function of your effort than my effort, because I think it does require effort to find things interesting. And I think the easiest way you see that is people that have like burned out from like school and stuff, and then, they'll kind of spend some time recovering, but some just like never kind of really recover. And when you look at people like that, I think what you often see is that not just school, but like nothing seems interesting to them. Like I don't know if you've really seen people that have like absolutely no interests. And I realize that, in a lot of ways that can be completely unrealistic, but there are people that are just, I guess, I mean, from what I can tell, they're just presumably so just burned out from like life that nothing is interesting. And I think that's an important part to keep in mind, that finding things interesting is actually a significant effort, like just in daily life, right? So if you find this stream interesting, I feel like this is the case with a lot of things. I think it's probably more that's a stronger statement of your effort or your ability to find things interesting than it is of me being interesting. So I think you can give yourself more credit, is I guess what I'm saying. You can give yourself more credit. And I think it's important to have the skill to find things interesting, because I think that skill is what gets you through what normally would be kind of tedious things, right? So good job is what I'm saying. I'm saying good job. I know it can be long-winded, and sometimes it's hard to tell if I'm actually complimenting people or not, and I do apologize for the ambiguity there, but this is supposed to be a compliment. Right. Anyway, But yeah, so beam waste and Rayleigh range. Rayleigh range, I did take notes. What is the Rayleigh range again? I wrote it somewhere in here. So I don't know. Let me just Google it. What is Rayleigh range? Rayleigh range of Gaussian. There we go. Any effort at all you can say whether you find something interesting. Well, right. It's well, I mean, so I mean, maybe you don't feel like it took any effort, but I you know, it's I guess what I will say is it's non-trivial. The ability to find something interesting is non-trivial. I think it can be sometimes easy to forget, but it is definitely non-trivial. So I mean, maybe sometimes easier than other times, but I think it's I mean, I suppose what I will say is that, when people are young, or even to like just kids in general, people will say like, oh, for a career, you got to find something that you like, or you do what you like, or do something that makes you happy or something like that, which is maybe a little different. But anyway, they talk about interests, and there's a lot of us, at least in the US, right, there's a lot of focus on people finding their that the thing that wakes them up, that gets them out of bed in the morning, right, that big interest that drives them, which I think is very true. I think it's very valuable in identifying such a thing, but I think there's often kind of an assumption that everyone has such a thing. And the point that I'm just getting at is that that's not necessarily always the case. Sometimes people just kind of just run out of, I don't know what it is really. It's just something just, runs out, and then they just don't know what to do. Um, and and again, I think one of the core, what do you call it, properties perhaps, that are one of the core things that can drive people forward even after they've kind of, run out of that kind of like will, so to speak, is that again, really just like the diligence, the ability to just find something interesting, which I mean, perhaps you could argue is in some sense like self, like, what do you call it, it's not like hypnotism perhaps, but it's like you're, in some sense, it's maybe not genuine, because you can, in some sense, it's forcing yourself to find things interesting, but I do think it's an important skill. However people, context, or however people kind of frame it, I think it's a non-trivial skill, and I think it's at best you never have to rely on it as a skill, but I think fundamentally it's something that everyone probably needs at some point in some capacity. So yeah. Yeah, sorry, kind of tangent, sorry. A Rayleigh range Z sub r is the distance along the propagation direction of a beam from the waste to the place where the area of the cross section is doubled. Oh, I see. So you take the narrowest part a beam can become, and then you say how far from that spot where it's as narrow as it can be, does it double, or does the beam double in size? And that is the Rayleigh range. Why is that important? For most ray optics, it is sufficient to predict the position of the beam waste in numerical aperture from which the waste radius. Okay. They're saying that if you have the beam waste position in numerical aperture, you can get the waste radius as well as how long it takes to diverge. Again, no worries. Again, I do in some sense really need these tangents, because this book, honestly, I think is much easier to read than before, or than some other books. Now, is it the best, or is it the easiest read? No, because as you can see, like every page, or every 2 pages or so, I have like multiple annotations. I don't want to write in the book, because this isn't my book. This is the office's, or I'm working in an office right now, but it's the lab's book, so, or our research group's shared property, so I don't want to write in it. But it's not like it's not a obvious read, right? Because I have to take, external annotations all over the place, but it is a little bit easier to read, but nonetheless it's hard to process. So, and I'm gonna be honest, it gets really tiring. I've been reading this for like 2 weeks already, and I'm only like a few pages in because I feel like every two paragraphs I have to do like several hours of research. Then it's like, oh, okay, this is what they mean by, evanescent coupling or something, So, so being able to kind of, pull myself out of the reading every once in a while to kind of relax is helpful. And I've mentioned this before, but if I can hard focus on the book, right? But I don't actually go that much faster. So having these little tangents is at least helpful for me. At the very least, it kind of processes my thoughts one way or the other, right? So yeah. But yeah. So anyway, so just to I can't quite remember what I was saying, but I guess I must have been talking about yeah, like the effort to find things interesting. It's maybe not something people consciously, put effort into, or maybe it's not a skill that people consciously train, but I think it's nonetheless a skill that is, trained and kind of refined over time. And, it is maybe not often really considered, but it is, I think, a very important thing. Because, like I think, most people at no matter what career path they take, they're going to reach a point where, you know, the work just sucks. I mean, hopefully it doesn't. You never reach that point. But I think the reality is, as long as people, continue to, whatever they do, they continue to, move forward and, I guess, I guess kind of advance or, move forward just as a person, right? Inevitably reach roadblocks, and inevitably as you push forward and forward, you'll challenge yourself more and more. And then eventually you, I would expect it's natural to reach a roadblock that you can't just push through with motivation alone, right? And then that's where I think the ability to, you know, become interested, to like train yourself to be interested in things, I think that's when that skill kicks in, which is again why I just said that. That's just the point I was making with why. Well, I expect everyone to have that ability to some extent. It's just by nature, and B, why I kind of think of it as presumably a necessary skill, right? So, um, yeah. Of course, I'm just a virtual anime character, talking into the void of Twitch. So what do I know, of course? But yeah, yeah. Don't take it too seriously. I mean, take the compliment. Take the compliment. I did mean the compliment earlier, but about finding this stream interesting. But at the end of the day, there's just someone rambling. So yeah. Where's yes, this one. I think I need to buy more post-its soon. I'm like halfway done with the stack. But okay. Uh, Useful invariants of this process. Okay, for the Gaussian beam whose waste scans back and forth by B waste radii, we transformed in the beam whose waste scans B times the new waste. What does it mean for a beam's waste to scan? Sorry, I need to process that sentence again. But yeah, don't feel bad about chatting. I mean, again, I think I might have mentioned this before, but like if I really need to focus on something, I can just stop looking at chat, right? It's not hard. Chat's right there. The thing I'm reading is, well, the book is down here, but the screen is right there. Like I can easily just not look at chat. So if I'm reading it, I'm choosing to read it. So don't feel bad. Yeah, sorry. So let's see. So which radius and Rayleigh range can be predicted? That makes sense because the numerical aperture in some capacity gives you how. Well, I guess fundamentally the numerical aperture, I don't quite understand what it means for a beam to have a numerical aperture. But for a lens to have a numerical aperture is to just say what is that largest angle a beam can have and still get through the lens. So whatever the analog to that is for a beam itself, must be this property. But anyway, you can use, but in some sense that kind of, I can imagine that encodes the how fast or slowly a beam kind of expands or contracts as it propagates through space. So it makes sense that you can use that information plus the position of the beam waist to then actually compute the radius of the beam waist, as well as how long it takes for that radius to expand to, say, double the size or triple or whatever the size, right? So that part makes sense. And then there are useful invariants of this process. For example, a Gaussian beam whose waist scans back and forth by b waist radii. So I assume, what does it mean by the waist scans back and forth by b waist radii? Transformed into another beam whose waist scans b times the new waist radius. So I don't know what the scanning process is, but I guess what they're saying is that if you have a process that modifies the waist radius of a beam, so that is like the radius at its thinnest point, and you transform that beam into a different one, say by going through like a cylindrical lens or something, and it warps the shape awkwardly. That process that initially modified the beam in some beam waist in some fashion will also modify the new beam by the same ratio. So I guess what they're saying is that, you know, like this process of scanning or whatever must be some, you know, it's like some numerical constant that's just multiplied to your beam. So when you change the beam, you still have that numerical constant doing the same relative effect, I guess. Oh yeah. I guess we should update those emotes at some point. They're I believe Konosuba, you made them for me early on when I started streaming. I feel a little bit, I don't really want to get rid of them because, you know, he went through the trouble of making it, so it seems kind of a waste to get rid of them. But maybe I should add some updated ones because that uses the old model. Actually, I've been meaning to bring back the old, maybe not bring back the old model, but it'll come back in some capacity, and I'm preparing for that. Yeah. I guess it won't come back as a live 2D model. Actually, it's the plan is to use it as a character to put in like song covers and stuff, because a lot of song covers, like the animation and stuff, you know, uses like multiple characters. So I was like, oh, I could use both. So I basically have two characters. One is the old model, one is this current one, right? So yeah. Trying to justify not getting rid of the old emotes, yeah. But anyway, so what was it? Oh wait, I didn't finish that. So a position c times the Rayleigh range of the waist will image to a point c times the new Rayleigh range. Okay, yeah. So it's saying stuff like this positional stuff. Like if you're taking some, these are all when you modify the beam, the process still retains its relationship. So if it's like, say, 6 times the old thing, it'll still be 6 times, but it'll just be 6 times of the new thing if you were to modify the beam and then do the same process. Which perhaps that's part of the reason why they call these linear systems. I mean, I know optically a linear system just means that, actually I'm not quite sure what that means. I know an isotropic, I believe, means that isotropic means that the index of refraction / the phase velocity of a wave in a some media is the same in all directions. So it's like identical in all directions. That's fine. But I guess part of the linearity of like linear systems, for example, I guess that's this whole process, you know. If you make a, you know, it's a what do you call it? What is the word? It's not a linear, do you call it a linear sum? Is that what it's called? A linear sum? A linear combination, that's the word. It's a linear combination. I remembered any word from quantum mechanics. It's a linear combination. This linear everything is a linear combination. Anyway, yeah. Yeah. So a corollary is that the number of resolvable spots, i.e. the scan range divided by the spot diameter, is also invariant. The scan range divided by the spot diameter. So we just established that the spot diameter, the spot position, is like some linear, or it's like it's a constant times the old one. So in that sense, it's linear. And then I guess the scanning is also. Oh, I see. So they're saying that if you're taking the spot diameter, which is something times the beam, and then the scan range, which assuming is also constant times the beam in some capacity, then the what do you call it, the quotient, I guess, of the two should also be linear in some capacity, and that makes sense because yeah. These invariants, which are not limited to the Gaussian case, allow one to juggle spot sizes, focal positions, and scan angles freely without having to follow them laboriously through the whole optical system. Okay, yeah. So I guess the TLDR of that is that they're just saying, you can make these observations and then see, okay, this is why in practice you don't need to worry about all of them, and you can just kind of do your basic optics and it'll work out. Which isn't a trivial conclusion. I think that's the whole point that they've made here is that the idea that you can just kind of treat it like a plane wave, and may not treat it like a plane wave, but you can use like plane wave assumptions and stuff. It's like that's not a trivial thing, but in practice, you can make approximations like using the paraxial propagator or something, and you can simplify a lot of things such that they kind of in practice kind of simplify nicely. So that's a good point. So they're just saying, it ends up working out rather nicely. That's I think fair. These are a bunch of properties of Gaussian beams, or sorry, parameters of Gaussian beams. Let's see. So Debye approximation for Fresnel zones and Fresnel number. Okay, so the plane wave decomposition of a given disturbance, don't know what they mean by disturbance, can be calculated from 1.25. 1.25 is the equation. 1.25 is the, what is this equation for? Theta is the envelope function. It is the argument. So U, which is equation 1.25, is the constant. Oh, wait, sorry, no. U is the plane wave spectrum of theta at z equals 0. So I guess U is an integral that describes the plane waves that make up your wave at z equals 0 in your system. Okay. That's why they say the plane wave decomposition of a given disturbance can be calculated with that, because, well, that's what that integral is. Let's see. Or its higher higher numerical aperture brethren in section 9.3.6, where I'm not at yet. Hell, I'm at 1.3.4. That's going to take ages to get to. Let's see. And those work regardless of where we put the observation plane. Fair enough. I assume you just change where z is and you get a different observation plane. When discussing the numerical aperture of a lens, numerical aperture of a lens, however, we usually use a much simpler method. Draw arrays representing the edges of the beam and set NA equals n sine theta, where n is the, numerical aperture equals n sine theta, where n is index of refraction. Okay. This sensible approach, so we draw rays representing the edges of the beam, fair, and set the numerical aperture equal to I see. You need to draw the edge of the beam because you need to get an angle to plug into the numerical aperture equation. And that theta in n sine theta. Yeah. Okay. This sensible approach, called the Debye approximation, obviously requires the beam to be represented by geometric optics, because otherwise we can't draw rays. Fair enough. Okay. It breaks down if you put the aperture near a focus, for instance. Sorry. Why does this break down when you get near a focus again? There's something about here about how, and I think this has to do with the paraxial propagator as well, one of our assumptions. I think there's something about how if you get near the, here it is. Let's see. So the reason why is as you get closer to the focus, I wrote something here. Right. So the point that was being made is that, or at least my guess is that, one of the prior assumptions we make is scalar optics, which is to say that we replace vector addition with just scalar addition, which, if the vectors are pointing relatively in the right or in the same direction, seems like a decent approximation. You know, if a vector is pointing up and then another vector is pointing up but slightly off, it's rough. You could roughly add the two magnitudes and then you'd still end up with a relatively good estimate of what the sum of the two vectors is. Obviously, if you have a lens, so your rays are focusing to a tight point, then at the edges of that lens, for example, the or what do you call it, the difference, well actually, the angles between them is the same though. So why is it necessarily at the focus that the issue shows up? So maybe it's not the angle that's the issue. Is it the... Yeah, well, why is this say... Well, okay, so I got to think about that a little bit more. But the point is that, right, we one of our earlier approximations, at the very least, does fail if you're near focus. I'm not quite sure why. Right, and that's why they say because we can't draw rays. So I guess, yeah. So the scalar approximation, I guess, helps with justifying the use of ray optics to approximate our system, and that fails near the focus, or that approximation breaks down near the focus. Hence, that's what they're saying. Okay. Let's see, we can crispin this up considerably via the Fresnel construction. In a spherical wave, the surfaces of constant phase are equally spaced concentric hemispheres. So on a plane, the lines of constant phase are concentric circles, corresponding to annular cones. Fair enough, okay. Annular is a fancy word. Annular meaning ring-shaped. Oh, can't they just say ring-shaped cones? They always got to use their fancy words. Anyway, let's see. Drawing these circles at multiples of pi radians divides the plane into annular regions of positive and negative field contributions called Fresnel zones. Okay. So I guess they say, okay, take a spherical wave, and then like chop it, and then draw where, or mark where, the phase of the wave is constant. And then if you look at the surface you just chopped, you should end up with concentric rings where, you know, some of them are negative and positive, or positive depending on, you know, what cycle they're on. Okay, and they say the zones are not equally spaced for a beam whose axis is along z hat and whose oh, it's because I had so much coffee today. Sorry, my stomach's kind of rumbling, but anyway. The zones are not equally spaced for a beam whose axis is along z hat and whose focus is at z equals 0. The angular zone boundaries of the far field. Angular zone boundaries. What is the point being made here? Is the angle important or? What is theta n? Theta n equals inverse cosine, so I guess arc cosine of 1 over some big thing with lambdas and f's, which are, I think, frequency. Oh, wait, if f is frequency, then... Oh, lambda is wavelength. That's what it is. Angular zone boundaries. I'm not quite sure. Yeah, so I'm assuming it's the angle that you draw these lines on the previous page, and the lines on the previous page just show where or the difference between a positive and negative field contribution is. So we'll go forward with that assumption. The Fresnel number n is the number of these zones that are illuminated. The number largely determines the character of the beam in the vicinity of the reference point, whether it's dominated by diffraction or by geometric optics. Anyway. I don't understand what they mean by how this Fresnel number determines the beam characteristics. So I guess for a beam to be diffraction limited, I think from what I understand means that it should be at its... Well, here, let's Google that. What does it mean for a beam to be diffraction limited? Diffraction limited system. The resolution of an optical imaging system can be limited by factors such as imperfections in lenses and misalignment. However, there is a principal limit to the resolution of any optical system due to the physics of diffraction. An optical system with resolution performance at the instrument's theoretical limit is said to be diffraction. Okay, yeah, that's fine. The diffraction-limited angular resolution of a telescopic instrument is inversely proportional to the wavelength of the light being observed and proportional to the diameter of its objective's entrance aperture. Okay. For telescopes with circular apertures, the size of the smallest feature in an image that is diffraction limited is the size of the airy disk. I have no idea what that is. Oh, sorry, so double check diffraction. Diffraction is defined as the interference or bending of waves around the corners of an obstacle or through an aperture into the region of geometrical shadow of the obstacle size aperture. The diffracting object or aperture effectively becomes a secondary source of the propagating wave. So is this stuff about how like if you have a little slit and then you send in a plane wave, it like spreads out into like a circular wave? Is that stuff? And that's why if you have two slits, it becomes this weird interference pattern. Yeah. Okay. So I guess by diffraction limited, I guess we're saying that okay, so diffraction is just that you've hit the point where the bottleneck in resolving an image in your system is now literally just the size of the hole your light is getting through, I guess. Like, so literally the physics of sending light through a tiny hole is the main issue, I guess, is the point of diffraction. And I guess diffraction limited means that the primary contributor to like noise or resolution in your system is now literally that tiny hole that you're going through, I guess. And then what this said in this book is that the Fresnel number can inform you about whether your system is dominated by diffraction or geometry, or the geometry of your system. Modesty, welcome back. How's it going? As you can see, I'm coming through this fucking long book again. I don't know, at some point I'm gonna give up and just skim through the book a little more because I've got stuff to do, and this is all fundamentals that I do plan on reviewing, and I think it's rather nice the way the book has everything sorted, but yeah, admittedly it still takes a long time. But yeah, how's it going? How's life treating you, I suppose? Did you have work today, or can't remember? Oh yeah, wait. How's your how was Eminence in Shadow, man? I don't know how far you got, but don't worry if you haven't gotten far. It's okay. Yeah. Yeah. So let me figure that out. So the Fresnel number n is the number of these zones that are illuminated. The number largely determines the character of the beam in the vicinity of the reference point, whether it's dominated by diffraction or geometric optics. So let's set that aside. A collimated beam has n equals 1 and is completely diffraction dominated. Why is... Oh, wait. Is that the point? So like if you have a beam that's entirely collimated, that means if you were to take this little, cut of it and look at the thing, there's only one illuminated spot, I guess, right? So that means if you go through any optics, the only resolution like decrease you could get could possibly only be from diffraction, because that's the only remaining property. Like it's like nothing, you've already have a perfectly clean beam is I guess the point if n equals 1. And if n is anywhere greater than 1, that means before you even go through the trouble of dealing with like diffraction, you're already getting some signal loss just by virtue of having these rings of non-zero amplitude around your main beam. Is that all that's saying? Maybe, I don't know. Much more fun to watch when I stopped reading the subtitles. Also, Ingrid. Yeah. Wait, how far did you get? How far did you get? Like if you got as far as I think you got, then there's one specific phrase that you should know. Did you get to the thing? Go to school? Starting to go to school. Oh, okay, you're almost there, man. Oh, yeah. Yeah. But let's see. So what happens before that then? I guess so hard to well, I mean, I guess yeah, the subtitles make it tough, doesn't it? That's fair. Um yeah, no, it gets better. Uh yeah. It gets better, but at the same time you shouldn't have to force yourself to watch it cuz again, it is one of those shows where I don't think anyone should take it seriously. I mean, the outfits are cool, but it's 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 an aesthetic show. Yeah, because the main character cares about aesthetics. Actually, wait, was that before school or? Actually, I guess here's the question: Has the main character gotten a girlfriend yet? I don't remember how hard it was, or I don't remember how far it was before he gets a girl. No, not yet. Okay, okay. After that part. Anyway, no, it's chill. Yeah, no worries. As long as you're able to get rest, that's good to hear. Yeah. But yeah. Well, it sounds like you got the caffeine out of your system, so that's good to hear. Uh, Built-in microphone. How is the quality of that? Just out of curiosity. Like, does it pick it up? Does it pick up sound when you're like, clicking the buttons and stuff? I actually don't know how clicky the buttons are, but no. But I've heard a lot of people use their console to stream these days, right? So catch his voice. I mean, I guess yeah. I mean, it's probably better than having a. It's probably than recording via the. What is it? What is the PlayStation camera called? Is it just called PlayStation camera? I don't know, but they have a camera, right? It's probably better than that for sure, at least proximity wise. Yeah. Listen to the stream. Oh, okay. So it must have some fancy. I mean, I have a hard time believing it doesn't catch the sound, so it must have some sort of, or I speculate that it has some sort of noise processing, noise cancellation tech somewhere in there. I wonder how it works. Yeah, right. Because it's usually very difficult to noise cancel when you have your microphone embedded into something that's like actively generating noise, right? Like, I suppose in some sense it's easy, but um, it's there's multiple noise sources so close to the microphone. It's from what I understand, it's usually considered kind of a hard thing, but yeah, maybe that's something. How hard is it to talk about playing a game or talk in general? Well, I mean, I can certainly relate. Yeah, no. I mean, you see me play a few games, right? It's easy to get lost in the game. Yeah. And I think that's pretty normal, It's I think the outliers are the streamers that can just do it like just, off the cuff. Yeah. Or actually, so the outliers are people like like Suichang, right? Because she can play Tetris while like regularly like interacting with her stream, and that is what I really don't get. Because I was talking to someone about this, about like, can people truly multitask? And I was like, I can't multitask, and apparently he can't multitask, and a lot of people can't multitask. But I have a hard time believing what Suichang is doing is not considered multitasking. Like on one hand you could be like, oh well, they're switching between paying attention to the game and and paying attention to chat, or oh, it's all reflex. But I'm like, I don't think Tetris is something that you can play purely by reflex, right? So she must be multitasking to some, in some capacity. Because it's so, like, she's just so fucking good. Like, and certainly when she'll focus super hard, she'll stop focusing on chat. But I have a hard time believing her everyday Tetris isn't already, an example of, multitasking. It's too, I guess, what do you call it? I mean, maybe it is just reflex, but I have a hard time believing, just watching the gameplay, that it's reflex. Yeah, like how much attention live streaming demands from me. Interesting. Interesting. Well, yeah. So how's the viewership? Wait, what platform does that stream to? Does PlayStation just run like a streaming platform or streaming service or something, or like how does that work? Twitch or YouTube? Oh, so you can just send like an RTMP stream. Interesting. Interesting. Okay. How do you watch chat then? Just off of your phone or something? Or I mean, I guess that makes the most sense, but I don't know. Can you like watch chat while you're playing the game, or I don't know, using your phone? Oh, okay, that makes sense. That makes sense. Yeah. Yeah, I was thinking like having chat on your screen while you're playing could probably get a little distracting, couldn't it? Yeah. At the same time, I guess having it on your phone is a little inconvenient. Maybe you can get one of those clips that like lets you clip your phone to your controller or something. Yeah, but then again, I guess you still have to look down at your controller. But yeah, yeah. How's the viewership? Are you gonna be the next? Are you gonna be the next? What's a popular video game or video game streamer? Are you gonna be the next XQC? I think XQC plays games, right? Is that right? Do you want viewers? It's just sending a blank RTMP stream to Twitch, being like, yeah, yeah. I mean, I think it's fine to stream though, right? Even if it's not, I mean, like I don't stream for viewers as well, so I don't think I have any right to criticize. Like yeah, I'm like the last person that should criticize, honestly. but but yeah, yeah. So wait, so random bots and unhinged randoms. So basically randoms. Yeah, no, that's fair. That's fair. Um, that happens. Well, just you wait. You're gonna be again. You're gonna be the next. You're gonna have like you're gonna. I don't know. Friends will show up. Oh, that's nice of them. Yeah. What games are you playing right now? Or wait. Did you say you got God of War, or am I misremembering? I know my colleague recently started playing the was it God of War Ragnarok? Is that right? I think that's what they're playing. I don't know where they find the time to play it, but evidently they're playing. Uh, but the nude one, right? The remake. Yeah, that's not. It looks good. Looks good. Wait. I thought Dead Space was a Xbox thing. Is it also on PlayStation? I guess it must be on PlayStation. You must be personal bragging rights. Yeah, that's fair. Just keep it on the record. Yeah, no, that's fair. That's fair. Yeah, I didn't realize it was on all platforms now. Or maybe the original. I don't remember though. I just remember playing the original Dead Space just a little bit, of course. But um, wait. Was the original Dead Space on all consoles as well? I thought I vaguely recall playing it on Xbox, or sorry, Xbox 360. Am I just misremembering? Let me look it up real quick. Games. Oh no. It says original Dead Space was on 360, PlayStation 3, and Windows somehow. Yeah. Well, I mean, yeah. I mean, I just remember playing it on 360. When did the PS3 version come out? Like, yeah, it's weird. Okay, whatever. I'm not complaining. I guess yeah. No, it looks like judging by the history of the franchise, it's been on. Usually, it's been on both PlayStation and Xbox. Yeah. Oh hell, there was a mobile remake too. It says Dead Space by there's some Dead Space port by Iron Monkey Studios was on iOS, Android, BlackBerry Playbook, and BlackBerry 10. They freaking ported it to BlackBerry OS? Like, wow. Yeah. Well, the crazy thing is the BlackBerry 10, right? Like that was still running BlackBerry OS. So like they really went out of their way. Like yeah. Yeah, Mass Effect I remember being an Xbox exclusive. I don't know if it was toward the end, but at least the first one for you was, I think, right? Yeah. Yeah. So how far you've gotten? For the record, I haven't actually played through Dead Space, so I don't remember the plot points. But I'm just wondering, like, are you mostly through the game, or just started, or so was I? So by approximation, valid geometric limit. Sorry. So we're talking about the Debye approximation. I don't really understand what the Debye approximation is. Possible at night frame. That's fair, right? Yeah. Okay. Yeah. Well, yeah. Sounds good. Sounds good. Make sure to what do you call it? Uh, Sorry, are you streaming to Twitch or YouTube? Reason why I ask is because if you stream it to YouTube, it should auto permanently archive it, right? Or you can set it up to automatically permanently archive it. I guess you have to set it up that way, but you can. Whereas Twitch will automatically delete VODs after 2 weeks, right? So your precious proof will vanish in 2 weeks unless you down. Oh, you are on Twitch? Okay, then make sure to make sure to download all your VODs so that your proof that well what's the point of streaming it? like dude, you're kind of contradicting yourself. Then use like VoiceRoid or something then. Like we have the technology, right? Like use like you're there, and that's fair, that is fair, that is true. If you're there, you are there, that is true. High tech, yeah. Well, I don't know if it's high tech, but um yeah. Maybe I can find a video on the Debye approximation. Deleted there. I mean, to be fair, that it's kind of does that not happen to you where you're like you write something right, but you're like, oh, I gotta fix it, even though yeah. That's fair. Um, yeah, I'm getting kind of sleepy. Okay, I don't really know what the Debye approximation is supposed to be. Yeah. But yeah, anyway, yeah, sounds good. I mean, I still feel like, well, I mean, it's gonna take a lot of hard drive space. That is fair. But, if you're gonna stream it, I feel like you might as well grab the VODs. I mean, the VODs will sit there for 2 weeks, so you're not really in a rush, right? But, you could throw it up on your YouTube later or something, right? In fact, you could stream to restream, but Twitch doesn't save VODs. Well, why the fuck did you do that? Yeah. Yeah. I mean, I suppose so. So this kind of pertains to streaming to Twitch, but one I don't know if it's a good thing, but one way you can spin this as a good thing, uh, is you know, if you stream to no one on Twitch, then you can justifiably talk to yourself because one of the things they say as a streamer is that you're supposed to be talking as if there's a viewer. So you should always keep talking as if there's a viewer watching, so that it's not awkward when someone shows up. So you can justifiably talk to yourself for hours on end. I mean, I feel like most people view that in the other direction where you have to and you're forced to talk to yourself for hours on end, but I mean, it's possible to spin it in a positive way, right? Yeah. So I do have to admit though, doing other stuff and talking at the same time is like, well, I can't do it, that's for sure. Yeah. I'll try to. Yeah, I don't quite get the importance of this. I wish there was a what do you call it? Wish there was a video that went with this book, to be honest. Hmm. For small numerical apertures, the position of the beam waist does not coincide with the geometric focus. For small numerical apertures. Hmm. On your about page? Fair enough. I mean, I feel like you could also lie about that, but but no, it's fair enough. It's fair enough. Yeah. Yeah. So actually, wait. So when you stream on PS5, can you put like a webcam and like show your face, or does it just stream just the game? Like what is there like an editor or like is there like a stream manager like OBS that you can use to set up your stream, or does it just kind of just stream the game in the place? Oh, okay, well that's fair, but I see. But so there are some at least some rudimentary configuration options then, I guess. Yeah. Kind of surprised, like just I see. I see. Okay. Yeah. Yeah. I'm surprised that, it's not the first thing I'd expect them to integrate into the game console, right? So, yeah. But I guess enough people must use the feature, right? Because they clearly invested money in it. If I remember correctly, I think the PS4 also had that, right? Yeah, right. So they must the fact that they retained the feature and presumably added more functionality, I guess says a lot about how much people actually use the feature. So just dude, it's okay. Don't worry about it. Well, the reason, I mean, I guess I would appreciate it, but I also worry that it might be a little bit of a like clickbait. Be like, oh, this Dead Space streamer is recommending this other person. Oh, I should watch them. They get here, it's like, oh, for small numerical apertures, the position of the beam waist does not coincide with the geometric focus, but is closer. This somewhat counterintuitive fact can be illustrated by considering a beam of 40 lambda and like, like, yeah. I mean, again, if you're okay with it, I would certainly appreciate it, but I do worry that it's a little bit misleading. No one is gonna care. I mean, if someone cared enough to click the link, I think they would care. Yeah. Yeah. But yeah, that sounds fun. So wait, did you finish God of War then? Because I thought, or maybe I'm misremembering, but I thought you said you also got God of War though. Again, it might just be my colleague. I get these things mixed up very easily, but so let me try this calculation here. They haven't touched it, just tried it out. Oh, okay, okay, yeah, yeah. And my colleague is apparently very excited about that game, so I was just curious. Yeah. Although he's such a busy guy, I don't really get. I don't understand where he has the time to do all these things. I'm honestly a little bit envious, but I mean, not really. I'm envious in the not really sort of way. Yeah. Yeah. Actually, although speaking of time, not really, but um I think I mentioned before I want to mod my laptop. Or did I? I might have mentioned it before, but the idea is I want to mod my laptop to put in like like to so that I could eventually bolt on like a CPU cooler to the bottom of it. Like what I want to do is I want to have it magnetic. Oh, LSA, welcome back. Didn't leave you. Oh, yeah, thanks. Yeah, I'll probably stream for a little bit. Probably I'll stream to 11 like usual, and then I'll probably call it a day. But yeah, thanks for popping by. You're probably at your friend's place in Mendoza, right? So so don't worry about us. Just focus on having fun and yeah. Or actually, I don't know how long you said you're going to be there, but yeah, don't worry about us. But anyway, so what I was gonna say is, I fix my yeah, totally. Again, no rush though, no rush. But yeah, we'll look forward to it. Yeah, yeah, we'll catch you later. Let's gotta yeah. So anyway, so what I was saying is, I want to be able to like magnetically like attach a CPU like a big CPU cooler, to the bottom of my laptop. That way, when I put it here on my desk to stream, I can just have the CPU cooler like magnetically like attached to it, and then when I have to take my laptop away, I want to be able to like pull off this CPU cooler really easily. But to do that, I need to cut a hole in the bottom of the laptop, right? So I've been waiting for someone on eBay to stock replacement bottom covers for this specific laptop, and I finally found someone. And it's $40, which is kind of expensive for, a bottom cover for a laptop, but I don't have to pay another $700 for the laptop, so by all means, right? So I might actually do that project. I gotta sort out a few more logistical things regarding that project, but I think eventually I can do it, so that'll be fun. That'll be fun. Yeah. So like that's one project, but like this colleague of mine, he's got like so many projects going on, and I'm like, how are you juggling all these things? Honestly, um, I mean, if I'm being really honest, I'm a little concerned about the progress of even our project because the main guy that kind of does stuff has he's been in a lot of meetings recently, so there hasn't been much project. I mean, like or progress. We have stuff to do. It's just no one's really available, and I'm kind of tempted to just do it myself, but it's also really not my job. Not that I don't want to do it. Like I'd rather do it, but I've already been kind of assigned separate work to focus on. I mean, that's why I'm reading, right? So, um, I've kind of been assigned separate work, and I don't really want to overstep my bounds, so to speak, right? So I haven't really commented on it, but it's like, ideally we would have had everything like done and tested like by tomorrow, really. But I don't think we're on track for that. So, uh, yeah. I mean, again, it's not really something for me to worry about. But the thing I need to worry about is again, these detectors that I made many months ago. But yeah, yeah, I don't know what's gonna happen. But all I can really do is focus on my own work, right? So, uh, anyway, yeah. All right, I want to try this calculation real quick. Sorry. So, I want this paper. I guess I also do want to grab a snack, but I always want to grab a snack. That's nothing new. I wish places were open later in the evening. I guess I wish not expensive places were open later in the evening. But anyway, that's the crux of the issue. They're all so expensive. All right, so they say for small numerical apertures, the position of the beam waist does not coincide with geometric focus, but is closer. So let's consider a beam with 40 lambda of radius. Okay. The Fresnel number, n equals r squared over lambda sub z. Is it sub z or lambda times z? I think it's lambda times z, actually, unless there is a lambda sub z. Let's see. I think it's lambda sub z, or I think it's lambda times z. Actually, how do you get lambda squared? Because, am I using this right? So the radius, right? So the beam waist radius is W naught, which equals 40 lambda. And the focal length, I assume f of the lens, is 10 to the 4th times lambda. I don't quite understand what's going on. Okay, so W naught, the beam radius, is a beam parameter. F is the lens, a parameter of the lens. Okay. So they say geometrically, the incoming beam is collimated. And the focus is 10 to the 4th lambda away. So it's like right here. Oops, I missed it. Whatever. That's a shitty drawing. Let's try that again. Let's draw the beam first and then draw the focus so we don't have to worry about aiming. 10 to the 4th lambda. And we say this width is 40 lambda. But the Rayleigh range, which I assume has to do with the... How do you calculate the Rayleigh range? I feel like the Rayleigh range, I just googled that earlier, right? Yeah. Yeah, Rayleigh range Z sub R, so Rayleigh range Z sub R is the distance along the propagation between the waist, where the area, or from the waist to the place where the area of the cross section is doubled. So I guess if the focus is here, then but they say in reality the Rayleigh range of the beam is 40 times pi over 4 spot diameters, or 1260 lambda. How the fuck do you get that? Yeah, how the fuck do you get 1260? So the Rayleigh range is the distance along the propagation. So, okay, so here. So Rayleigh range, we have an equation here. We have Z sub R equals pi W naught squared over lambda. We have, well, let's leave lambda. We then have W naught, so that's pi times W naught, which we said is 40 lambda. So 40 lambda quantity squared over lambda. So we get 40 squared times pi times lambda for our Rayleigh range, Z sub R. So that's 1600 pi. How the crap do they get this? We don't get... See, it's trivial calculations like this that... It's supposed to be a trivial calculation. It's always supposed to be trivial. Don't have information about the numerical aperture. Mm-hmm. I don't know. Oh, TSMC. Yeah, should I apply for an internship at TSMC? That'd be interesting. Hmm. Okay. So, so the first question, I guess, is how do they calculate the Rayleigh range to be what it is? Um, I have an equation in front of me. It says, for a Gaussian beam propagating in free space along the z-hat axis with wave vector k equals 2 pi over lambda, the Rayleigh length is uh, z sub r equals pi w naught squared over lambda. And in that sense, I think we have enough information. W naught is the beam waist um, in terms of its radius. And we do have we have a collimated beam for which the 40 lambda beam waist radius was measured. So, well, it's collimated, but I guess it's still Gaussian. So, let's see. So, what does that mean? So, I guess I have the size of the beam, but I don't necessarily have its beam waist, I guess. Yeah. You have its radius, but that's not necessarily, or that's the original beam, and that doesn't necessarily say anything about the beam waist after it goes through the lens. So I guess, So I guess first thing we need is that proper value. How do I figure the fuck that out? So what did we say earlier? We said something earlier about needing certain pieces of information. Uh, well, okay, so we were talking about the Debye approximation. We talked about how a collimated beam has a Fresnel number n equals 1. So maybe let's start from there. So, yeah, so what is the information we get? We get the beam is collimated. That implies that Fresnel number n equals 1. We have the beam radius, which is 40 lambda. And we have the lens information. Let's see, so the lens focal length is 10 to the 4th lambda. Placed at its waist, whatever that is. Okay. So if the Fresnel number n equals 1, then we don't have the index of refraction, but I guess we have this Fresnel number equation, which is Fresnel number n equals r squared over lambda sub z. We're still not sure what lambda, again, is this lambda sub z or is this lambda z? I think it's lambda z. Yeah. So whatever, so that's 1 equals r squared. R is the radius of the illuminated circle. So radius of where the illuminated circle is that the hemisphere pattern thing, or the ring pattern we talked about. Whatever. So I guess we then get lambda z equals r squared for Fresnel number n equals 1. So we still only have the beam radius 40 lambda, which I guess is fine because it says it's I guess that's the radius of the illuminated circle in some sense. And then we have lambda times z here. Lambda times z. So I guess if we factor out the lambda, we get z equals 40 squared lambda. There's no pi or anything. You know, this is taking too long. All right, so yeah, let's skip that. Okay, so we all know that the way you check for a board, or check a board. What do you mean by a board? Never. We all know that the way you check a board for warpage is by sighting along it because light in a homogeneous medium travels in straight lines. Okay. The departures of light from straight line propagation arise from non-uniformities in the medium, as in mirages, and from diffraction. Most of the time, these are both small effects, so light can be well described by rays. Thought of as vanishingly thin pencil beams, whose position and direction are both well defined. The usual mild weirdness exhibited by asymptotic theories. I don't know what I mean by that. Ray optics does not require paraxial approximation or even scalar waves. In the absence of diffraction, i.e. as lambda approaches 0, the direction of propagation of a light beam in an isotropic medium is parallel to the gradient of the phase. They say look at section 9.2.3, so we'll skip that. This means that a beam whose phase fronts are curved is either converging or diverging. Fair enough. So a phase front is the same thing as a wave front, and it purely means it's a line or surface that denotes where this beam or this wave has constant phase. So, along this curved way, or this, say, a plane wave, say, for example, would have the same phase no matter what point on the plane you selected. Now, if you move the plane without moving the wave, then the points in the plane would have different phases, but very least everything in the plane has the same phase. And they're saying, well, if that was not a flat plane, but rather a curved plane, then what that suggests is your wave is diverging or converging, which I think you can kind of imagine. Well, I think makes intuitive sense, because if you were to say take a curved plane and it's like a chunk of a sphere, then so then you could kind of visualize a curved phase front or wave front, or this thing we've been talking about. You can imagine this curved surface as being part of a circle. So as this curved surface or you can imagine that, if it's part of a circle, that means this wave must have essentially either started out at the center of the circle and started moving outwards, or alternatively, it started from the edges of infinity and started shrinking towards the center of this hypothetical circle that we talked about. So it's either, depending on if it's heading outwards in that hypothetical circle, it's either diverging, or conversely, if it's going towards the center of that hypothetical circle, it must be converging. Excuse me. So it makes sense that, so this statement that um, a beam whose phase front is curved is either converging or diverging, I think also makes sense. Anyway, they say this means that a beam whose phase fronts are curved is either converging or diverging, and that rays can be identified with the normals to the phase fronts. Rays are the basis. Yeah, okay, yeah. So they're saying you can identify or I guess you can identify such curved wave fronts or just phase fronts in general as through the vector normal to that surface. And I think that's also a fair point. Okay. So a simple example of the use of ray optics, as a simple example of the use of ray optics, consider a 35mm camera to take an artistic head and shoulders portrait of a friend. For portraits, the most pleasing perspective occurs with a camera to subject distance of a few feet, 4 feet, about 1.3 meters, being about optimal. What focal length lens is required? The film frame is 24 by 36 millimeters in size, and the outline of a human head and shoulders is about 400 by 500 millimeters. Thus, the desired magnification is 24 over 400, or 0.06. Then they remind us the rules of thin lens optics are rays passing through the center of the lens are undeviated, rays entering parallel to the axis pass through the focus, and the locus of ray bending is the plane of the center of the lens. The locus of ray bending plane is the plane of the center of the lens. Yes, okay. So then I guess they draw this diagram. So I'm not going to draw on it, but we'll kind of trace it. Or I guess I could draw on it. Getting really tired, but whatever. Okay. So our desired magnification is 0.06. Oh wait, let's see. So the similar triangles in figure 1.4, yes, show that the magnification M is di over d naught, where d naught is the distance from the objective, or from the object to the lens, and then di is the I guess so from the camera to the lens, or the thing that's the film, I guess, to the lens, and then di is the distance from the lens to the image. Fair enough. Okay. Which I guess we established that is the magnification. And elementary manipulation of the geometric identities shown yields 1 over d naught plus 1 over di equals 1 over f, and anyway, so combine these equations, we get f equals m d naught over 1 plus m, or 73.5 millimeters. Since the optimum distance is only a rough concept, we can say that a portrait lens for 35mm photography should have a focal length of around 70 to 80 millimeters. Okay. Don't quite understand what they did here. Oh fuck, I'm so sleepy. Oh, I guess there's some soldering I wanted to do. Don't forget to hydrate. Actually, that's a good point. Yeah, let me get a drink. I had some tea in here. Let's try to choose tea that doesn't have caffeine in it because. Oh, actually, let me have some hot chocolate. You know, I actually bought a whole carton of milk, and I'm I gotta head back to LA on the 11th, so I should, you know, I need to be on track to use up the milk. So let's actually have some hot chocolate. Actually, I don't think I should use too much of this because I eat cereal every morning, but maybe not every morning, but it's okay. It's also kind of warm for hot chocolate, but you know, whatever. Spoon, spoon. Should I see the thing? There we go. Nice and hot. Just realized or I was just thinking, this hot chocolate doesn't have caffeine in it, does it? Don't really think that far. Like, I wouldn't expect it to, but also, this is America. Would I be at all surprised if they just added something random into your drink? Honestly, not really. Yeah. It's a little hot, actually. Sorry. There we go. That's better. A little hot, but yeah. Well, it was a little cold today. I think it's appropriate. Yeah. Although, yeah, especially since I guess I really needed this in the morning, I think. So so you know, I mean, maybe you can take the hint here, but um so technically students aren't allowed to live on campus, or like to stay overnight on campus, right? Um Now, ignoring the fact that I have a sleeping bag here, and ignoring the fact that I actually have spare bed sheets here, and ignoring the fact that there's a couch right behind me that's already had both of those things prepped ready to go, um, let's just say I totally am not spending the night here, just hypothetically. We're just just to, or not hypothetically, but like I think you can kind of understand what I'm getting at, right? I'm not, like if we're speaking on the record, I technically am not, staying on campus, right? But let's say hypothetically I did last night and I was planning to today. I also have card access to a building that has a shower, and the water heater there has had an issue recently where um the temperature is a little cold. So if anything, I kind of needed this hot chocolate this morning after I got out of the shower. Probably need it tomorrow morning too, but uh, yeah. Although, but jokes aside, evidently people don't seem to care. I mean, I guess it's not that they don't care, but um, I mean, the reading that I'm doing right now um, is pertains to work. Like, this is regarding the project that I'm working on, or at least it's learning so that I better understand the project that I'm on. So, people pass across our office all the time, but I think they kind of let it pass um, because, it's not like I'm holding a party in the office, right? I'm studying. So from what I understand, it's probably not looked highly upon, but at the very least, I think the professors and other staff around here kind of let it go. Because at least I'm not, like I'm actually doing work. Yeah. Same with the rule there. I guess let's go whether they enforce it. Yeah, like from what I understand, some of the other professors have enforced it within their groups, but I mean, part of it's the thing. Part of the thing is that our professor is rather understanding, to be honest. And I'm not literally living on campus, right? I have a proper address and I do pay rent. It's just, um, like days like today where I've kind of studied until late. I don't really want to head home at 11 o'clock, right? So it's a little dark. There's almost every week there's some report about someone getting mugged on the way home. It's like, I'll go home a few times. Like I go home a few times in the week, but I'll maybe spend every 2 days on campus or something, and I just figure it's safer that way. But so I don't actually save that much money on rent, um, but yeah, so unfortunately, so this was great when the shower was like properly warm and stuff, but recently it's been a little bit cold in the morning, so so it doesn't really help that, it's like it's cold in the morning and the showers are running a little cold, so it's like, yeah, I really could have used the hot cocoa this morning. Yeah. Yeah. Tech junk. Well, actually, thanks for reminding me. No, I'm joking. Um, well, so the most recent thing that I haven't actually had the chance to take home yet. Let me see what it's called again. It's Precision Component Analyzer. Now, I don't think it's considered precision these days, but at least at the time, so this was, this is something that was built in like the 90s. At the time, is considered a precision component analyzer. Mainly, you would use this device to measure the characteristics of like or of say like capacitors, resistors, inductors. Um, but it's very nice because you can measure it on different frequency settings. Because the properties of such devices isn't necessarily consistent across frequencies, right? You especially see that with like say an inductor or capacitor, right? Those are especially frequency dependent. But even a resistor, just normally, right, isn't necessarily frequency independent. So I found one of those and I turned it on and it seems to work. So I plan to keep it. And also, this is the really weird find. There was what's it? A Dell XPS 8900, I want to say. I popped it open. It is a 6th gen Intel i7 system with 8 gigs of RAM. And besides the fact that the hard drive was like on its last legs, the computer was totally fine. Oh, and it had a GTX 745 in there. I had only ever heard of that model number. The 745 is such a strange model. So it's numerically 700 series. But the actual silicon it uses is Maxwell. So 700 series is Kepler, right? Is Kepler silicon, usually. But the 745 is, I guess, a 700 series, like, it's not a rebadge, but it's just like nerfed Maxwell hardware with a 700 series label. Very strange part number, but it was in there. So it was actually a very nice computer because besides swapping out the drive, it was like totally fine. I ran memtest with it to make sure the memory was like alive. It works. Like I just don't understand why someone threw it away. It's like just swap the hard drive. It's not that hard. Side I could, honestly. Especially with all the monitors I found. I could totally just flip these monitors for like 20 bucks a pop or something on eBay, or on, maybe not eBay, I don't want to pay shipping, but Craigslist for sure, right? The issue I have with that though is, one, I don't want to deal with people being like, you know, this monitor isn't as described, you know, I don't want to deal with shit like that. Like, they should understand, like, you know, like, not that that's happened before, but I don't necessarily want to deal with that shit. And also, technically, I'm not supposed to be pulling them out of the recycling, right? Um, they're technically supposed to be disposed of properly, and I just kind of swipe them before they get picked up by the recycling company. So, um, you know, I've been keeping it just so that I don't have to deal with the whole legality of, you know, interfering with the proper disposal of, or the proper destruction of, you know, university property, right? So, um, but yeah, it's been great. I have at home, I don't use my computer at home, which is why this is extra stupid. But the computer at home that I have has 8 monitors set up now. 3 of those are ones that I've personally bought or acquired over the years. You know, one is actually, one of those monitors is a 900p monitor that I bought in like, when was it? It's super old. And then one of them is like an ultra wide monitor that I bought more recently, but it's like, yeah, but that's the thing, is I think at the time it was like 6 monitors, right? So I actually got 2 more monitors after that. Well, actually, so that's the thing. It's not actually, I got 4 monitors after that, if I remember correctly. And the difference is that I swapped out 2 of my old monitors. So I'm not using my 1440 by 900 or my 1600 by 900p monitor anymore. Now all my monitors are at least 1080p. Because I picked up so many. Like, it's hilarious because it's been cold recently, right? Just because it's winter. But I don't need to turn the heater on in my room because I just have to power the monitors on. So now so it was, that was more of a fun project. Like, you know, you could ask, why do you need that many monitors? And the answer is, I really don't. After I got past 6, I really stopped needing them. Um, I want to say up to like 5 or 6, I think you can make a justification that really anyone could make use of them. But after that, it is a little ridiculous. It's also annoying to set up, but yeah, so now my entire home setup is all at minimum 1080p. So that's fun. Yeah. Well, it would be fun if not for the fact that I'm never home. Like, I set it up once, I was like, okay, this is cool, and then I just went back to work. Back to the office. So, yeah. I suppose I should sell it at some point because it really doesn't serve me any good. But a lot of them are like dinged up monitors and stuff. Some of them are scratched. Um, it doesn't really bother me when I'm using it, but I'm sure it bothers someone. So I don't really know if they have much resale value, but um, so resale value. But yeah. Yeah. Well, anyway, it's winding around 11 o'clock. I'm getting pretty groggy, so I think I'll probably call today. So I kind of want to go to the bathroom. So, but yeah, so okay, so thanks for staying till the end. I guess Monoristi might also be there. I'm not quite sure. He might have gone to sleep by now. But yeah, everyone, and I guess LSAO also said he'd leave it on. So thanks to LSAO for popping by as well. Let's see who else came by today. I think that was it, right? Yeah. So yeah, everyone that came by, thanks for coming by. Take care, stay safe, have a good evening, and I'll catch you guys. Excuse me. I'll catch you guys whenever. Yeah. お疲れ、おやすみ、終わり。